Have you ever wondered how a mosquito can find you in the dark? Picture this. You're outside on a summer evening, no light, barely a breeze, and yet within minutes, a mosquito zeroes in on you like a guided missile. How is that possible? They don't have night vision goggles, they don't have GPS, and they're not listening to the faint music from your earbuds. And yet, they always find you. This mystery is so powerful that scientists often compare mosquitoes to living drones, equipped with sensors so advanced they rival military technology. The surprising truth is that they are guided by invisible signals you constantly produce without even realizing it. Let's start with the first and perhaps the most obvious clue: carbon dioxide. Every time you breathe out, you release a little cloud of CO2. To us, it's invisible, but to a mosquito, it's like a glowing neon arrow pointing directly to your face. Imagine walking into a dark room where someone has sprayed perfume. You can't see the perfume, but you can follow the scent trail until you bump into the person who sprayed it. Mosquitoes do the same with CO2. Their antennae have specialized receptors tuned to this gas, and they can detect it from more than 10 meters away. That's like you smelling a single cookie baking on the other side of your apartment. So the very act of breathing is already sending out a constant signal: dinner is here. But here's the twist. Carbon dioxide alone doesn't give them enough precision. It tells them roughly the direction, but not the exact landing pad. Think of CO2 as the lighthouse beam, visible from far away, but not enough to guide a ship into the narrow harbor. For that, mosquitoes use another sense: heat. And this is where it gets really fascinating. Your body constantly radiates warmth in the infrared spectrum. You don't see it, but a mosquito does. To them, you are glowing like a furnace in the night. Even a small patch of skin exposed between your shirt sleeve and your watch strap is like a bright hotspot. Imagine being in a pitch-black forest and suddenly seeing a campfire through the trees. That's what your skin looks like to a mosquito's heat sensors. Now combine those two signals, CO2 and heat, and you already have a biological radar system. But mosquitoes don't stop there. They have a third trick: molecular sensors for skin chemistry. Your skin constantly releases a cocktail of chemicals: lactic acid, ammonia, fatty acids. To you, it's nothing. To a mosquito, it's like a complex fingerprint. Some of these molecules even leak through your clothes in tiny amounts, which is why a mosquito can sometimes bite you through your shirt. The fabric doesn't block the chemical trail. It's like trying to stop the smell of garlic with a piece of paper. It still gets through. Scientists have discovered that mosquitoes are tuned especially to lactic acid, which your muscles release when you're active. So if you've been exercising or just walking around, you literally smell more delicious to them. Let's pause for a second. Step back and think about this. A mosquito is a tiny insect with a brain smaller than a grain of salt. Yet it runs a 3-layered detection system: long-range CO2 tracking, mid-range heat sensing, and close-range molecular fingerprinting. This is the insect equivalent of radar, thermal imaging, and chemical sensors all rolled into one. No wonder they seem unstoppable. If a military engineer built a drone with these exact features, we'd call it cutting-edge technology. But nature handed that blueprint to mosquitoes millions of years ago. Here's a helpful analogy. Imagine you are blindfolded and asked to find a friend in a dark park. First, you hear them calling your name. That's like the CO2 trail, guiding you in the general direction. As you get closer, you feel the warmth of a campfire where they're sitting. That's the heat signature. Finally, when you're right next to them, you recognize their favorite perfume. That's the chemical fingerprint. Step by step, you home in with greater accuracy until you find them perfectly. That's exactly what a mosquito does every night. You might wonder, if mosquitoes are so advanced, why don't they just bite anything that breathes? Why you and not the person sitting next to you? This is where individual variation comes in. Not everyone releases the same cocktail of chemicals. Some people emit more lactic acid or have skin bacteria that produce certain scents, making them irresistible to mosquitoes. Others naturally give off a less attractive chemical profile. In a way, your body odor acts like a personal advertisement. To some mosquitoes, you're a 5-star buffet. To others, you're a boring salad bar. Scientists even found that identical twins attract mosquitoes at nearly the same rate, while non-twin siblings don't. This shows that genetics plays a major role. Your DNA partially determines how tasty you smell. Now, let's bring in another layer: movement of air. When you walk, your body stirs up microcurrents, and your warmth creates convection, lifting your chemical trail upward like smoke from a candle. That's why mosquitoes often circle around your head. They're literally following the invisible smoke of your breath and body heat, rising into the night air. Even if you wave your arms, you're just spreading the signal around more widely. It's like waving a flashlight beam while trying to hide. It only makes you more visible. And here's the kicker. Mosquitoes don't just rely on one sense at a time. They fuse all this information together. Their tiny brains integrate chemical, thermal, and visual cues into a single map of your presence. Yes, visual too. While they can't see like we do, they are sensitive to contrast and movement. That's why they prefer dark clothing. It stands out against the sky at dusk. So if you're outside at night wearing black, exhaling CO2, radiating warmth, and sweating after a walk, you've basically switched on a neon sign that screams, "Mosquito buffet is open." This triple detection system is astonishing, but here's where the moment of Eureka really comes. Think about how we humans design machines. We usually pick one main sensor, say a camera, and then try to improve it endlessly. Mosquitoes took the opposite approach, combined multiple imperfect signals, each of which alone isn't reliable, into a near-perfect detection system. That's the genius of nature's design. It's redundancy plus integration. If CO2 drifts in the wrong direction because of the wind, heat still gives the mosquito a clue. If heat is blocked by clothing, skin chemistry leaks through. If chemicals are faint, the CO2 trail leads the way. One channel always fills the gap left by the other. That's why mosquitoes almost never miss. And here's a mind-blowing fact. Researchers studying mosquito navigation are actually using these principles to design better robots and sensors. Machines that can locate gas leaks, detect humans in disaster zones, or even sniff out diseases like malaria in breath samples. The mosquito's radar is not just an annoyance for us, it's a model for future technology. Once you see it this way, the buzzing in your ear becomes not just a nuisance, but a reminder that you're up against one of the most finely tuned biological detection systems on Earth. But our journey doesn't end here because there's still one more level of understanding left. We know the signals, we know the integration, but how exactly does a mosquito's brain, with so few neurons, manage to fuse all this information and act on it so precisely? And what does this tell us about the hidden rules of sensing and decision-making in biology? That's what we'll uncover next. So how does such a tiny brain put it all together? You might imagine a mosquito as a little flying computer running calculations every millisecond. In reality, it's even simpler and more brilliant. Their nervous system works more like a filter than a calculator. Each type of sensor, CO2, heat, and chemical receptors, sends signals to different parts of their brain. Instead of building a picture the way we do, the mosquito responds to the strongest signals at any given moment. Think of it like playing a game of hot and cold. If the CO2 signal grows stronger, the mosquito flies that way. If the heat signature increases, it adjusts again. If it smells more lactic acid, it makes a final correction. Step by step, it homes in without ever needing a conscious plan. This is insect autopilot, and it's astonishingly efficient. Now let's flip the perspective. Imagine you are a mosquito about to begin your search. The world around you is mostly dark and blurry. But in your sensory universe, the air is filled with gradients, patches of gas, warm streams of rising air, and faint chemical trails. To you, a human body doesn't appear as a body. It appears as a glowing cloud of warmth, with a pulsing core of CO2 and a surrounding halo of sweet, irresistible molecules. It's as if someone turned on a giant neon sign that only you can see, pointing the way to the next blood meal. And remember, for mosquitoes, finding blood isn't optional, it's survival. Females need the proteins in blood to produce eggs. That hunger makes their sensory radar even more relentless. This also explains why mosquitoes seem unstoppable at night. They don't need light the way we do. Their guidance system isn't based on vision, but on invisible signals that don't disappear in the dark. The night sky may hide stars from us, but it does nothing to hide you from them. In fact, nighttime is perfect. Cooler air means your warm body stands out even more. Still air lets your CO2 linger instead of dispersing. It's the ultimate hunting ground, and you are the glowing target at its center. Here's where the analogy to military tech becomes irresistible. A heat-seeking missile locks onto the infrared signature of an aircraft engine. A radar system detects signals bouncing off a moving object. A chemical sensor identifies leaks in the air. Mosquitoes combine all three, but in a body small enough to sit on your fingertip. The difference is that their system is biological, evolved over millions of years, not engineered in a lab. And here's the twist. Human engineers are now studying mosquitoes to build better sensors. Imagine drones that can track disaster survivors by their CO2 and heat, or medical devices that detect illnesses by analyzing tiny chemical cues in breath. What annoys you at a picnic today may one day inspire life-saving technology. But of course, once you understand how mosquitoes find you, a new question emerges. How do we hide? People have tried everything: nets, sprays, even clothing designed to block signals. Repellents work by masking your chemical fingerprint, confusing the mosquito's radar. Some chemicals interfere with the receptors in their antennae, making it harder to detect CO2. Others overwhelm their smell sensors with false signals. Think of it like jamming an enemy's radar with static. But even with our best tricks, mosquitoes adapt quickly. They evolve resistance to repellents, shift their feeding habits, and keep coming back. In a way, it's an arms race between human technology and insect biology. Here's another mind-bending detail. Mosquito attraction doesn't just depend on your chemistry. It also depends on your microbiome, the bacteria living on your skin. Those bacteria break down sweat into new molecules, some of which smell incredibly attractive to mosquitoes. So when two people sit side by side, one may get swarmed while the other is ignored. The difference isn't just genetics, but also the microscopic ecosystem covering their skin. You could say that mosquitoes aren't just smelling you, they're smelling your microbes. That's why even identical twins with similar DNA can sometimes have different levels of attractiveness to mosquitoes, depending on their microbiome balance. All of this builds toward a striking realization. What feels like random annoyance, the mosquito finding you in the dark, is actually the result of a highly tuned, multi-layered detection system. It's not magic, it's not luck. It's physics, chemistry, and biology woven together. CO2 reveals your breath, heat reveals your body, and skin chemistry reveals your unique fingerprint. Layered together, they create an invisible beacon you can't switch off. To a mosquito, you're never really hidden, even in pitch black night. And this leads us to the Eureka moment. Mosquitoes aren't just pests. They are nature's proof that intelligence isn't always about big brains or conscious thought. Sometimes, intelligence is about building the right sensors and combining them in simple but powerful ways. A mosquito's radar is proof that evolution can produce systems that rival and even surpass our machines, all inside an insect we can squash with a fingertip. That perspective flips annoyance into awe. The next time you swat one away, remember, you just defeated a flying biological marvel, one of the most advanced hunters of the invisible world. So why does this matter for you, beyond winning trivia at a barbecue? Because it changes how you see the world. It shows you that every breath, every movement, every chemical trace you leave behind is part of an invisible ecosystem. Mosquitoes tune into it, but so do other animals, dogs, sharks, even some plants. Once you realize this, you start to sense the hidden networks that shape our lives, networks we usually ignore because we can't see them. Understanding how mosquitoes find you isn't just about avoiding bites. It's about realizing how much more is happening around you than meets the eye. And that's exactly what we do here on How It Actually Works. We take something ordinary, like an itchy mosquito bite, and reveal the extraordinary science behind it. If this journey gave you that Eureka moment, hit like, share it with a friend who always seems to get bitten more than you, and subscribe to How It Actually Works. Because the more keys to curiosity you collect, the more the invisible world around you starts to make sense. And trust me, the next time you hear that high-pitched buzz in the dark, you'll know exactly how they found you.